All right. Welcome, everybody. Welcome. And we're going to start tonight with Team Hex. We also have Team Heat, Rails, Car Seat, and Skate following that, and they're just going to follow one another. You ready, Team Hex?
All right, so our idea for our senior project was a universal hex key. And I'm Ryan.
I'm Jake.
I'm Trent.
So for our problem statement, basically our kind of look at the whole universal hex key idea is just have one single hex key instead of having those big sets of hex keys that when you lose one hex key, then it's basically the whole kit's not usable anymore, right? So in order to prevent losing one, we figured we'd just combine all of them into one tool, and then that way hopefully it'd be not as hard to lose the one key that you always use, because it'd all be together. And then this is a quote from a forum, basically from a machinist forum. It talks about how this guy, he basically only used 5mm and 5/32 hex keys, and every time he goes to look for it, it's gone. And he has to buy either a whole new set, or he has to go through the trouble of finding just one single hex key, which is nearly impossible.
All right, and then this is our first competitor. It's a hex key set from Amazon. The price averages around from $13 to $18. The hex keys are poorly made and cheap and are kind of easy to break. And if you lose one piece, you have to rebuy the whole set. And then this is the Craftsman hex key. This is set at a price of $39.95. And it's not poorly made, but if you lose one piece, you have to pay $40 for one piece. And then our third competitor is the Telehex, which was a Kickstarter. The price was set at $11.30, and it was made for bikes. The reviews on this product said the people who actually received it, that it fell apart immediately and was pretty poorly made. And then this is just a similar solution matrix for the three competitors.
So this is our justification for the similar solutions. We wanted a design that would be more cost effective than the $40 hex key sets, and then also the Telehex, which was $11.30. Hopefully you can keep in your car or take it to work and then bring it home if you need to. Or even like with the bike, you could put it in a backpack if you do like mountain biking, and you could use it on your bike. And then we also want it to be easy to use, obviously. I know like some tools can be frustrating to figure out how to use, so it'd be more like looked at if it was easy to use. And then we want it to be durable, and yeah. So this is kind of our first design. We got a lot of little rods, basically. This is an overhead view, this is a side view, and then this is going to be a cross section of the tool. And so in the handle, there would be little ball bearings at the bottom that would, when you use the tool, you push it onto a screw, and then it would push the rods into the handle, into the ball bearings, and then they would kind of use pressure to hold the size. We kind of ruled out this design just because of how many little rods you would need to actually have it usable and accurate to the sizes that you were trying to use. And then also trying to retain the ball bearings inside would also be complicated to try and put into a handle.
This is our second design. It's similar, but the difference is the size more compact, and the ball bearings, we roll those out for a different type of material that's more spongy, like a mesh of some sort. And it would be much lighter, much easier to carry around with the same problem with a bunch of small rods. It'd be hard to put them This is the third design. This is just a sketch that helped us come up with the box cutter selector, how you can select how much of the blade sticks out. That's where we got that idea from. After those designs, we decided to use that box cutter selector and then like a kind of telescopic X key, different sizes that way.
And then this is just a similar solution matrix for the three and showing how the box cutter went out versus the other products designs. And then our first design is a hexagonal component that's tapered down to try to have all of them become flush. And we just couldn't figure out the taper to get it right, and it just wouldn't fit inside the bolt. And our second design is a hexagonal piece with a thin layer on the inside. And we had the same problem that we weren't able to fit all the sizes into a bolt.
This is the third and final design. It was opposite of the second one where it caught on the outside rather than on the inside. So that way, if you're using the biggest size, the two smaller sizes can slide up out of the way. And then we'd use a spring or gravity to hold them in place until you select which one you want.
So this is more of the box cutter design. Basically just shows our the use of the spring, pushing the two other sizes, the two bigger sizes forward, and then gravity just hold the smallest of the three sizes out.
So I kind of reverse engineered a box cutter, and that's where we got the 3D print at the top where it has those little grooves and then the little rails to hold the selector on, and then the X key sizes fit into place on the end.
And then this basically just ended up being our final prototype. We have our selector that would push the three sizes out with our little kind of like a switch little mechanism that would skip in between the sizes. And then so when we began prototyping, we discovered that the handle of the hex key was too thin, and then it actually broke. So we had to reprint a couple times, make the handle a little bit stronger, just so we can actually spin the tool and use it. And thank you for your time.
And if anyone has any questions, it's like open question for the team.
Julie?
So you said it has like a little box cutter like spring inside, so you just use it upside down?
We could use it upside down, yeah.
Okay.
Go ahead.
So like, is it gonna have like the same like number of like sizes as like a normal?
So that we were thinking about that too, and with the 3D printing, it would be the prints would be too thin and they wouldn't be as durable if we did like the smallest size. So at that point, it would have to be machined out of metal and stuff like that. We don't have that kind of machinery. So for prototype reasons, no, but if you were to further this project, then it would have to be machined to get the actual sizes.
So how many sizes were you able to accomplish with your prototype?
We were able to fit 3.
And we made bolts.
And then we got we printed little bolts as well for the 3 sizes that we were able to print, and we were able to end up using all 3 sizes for it. Yeah.
So if you guys can put that on the middle table, then if people want to stop by afterwards and take a look at it. That'd be great.
Looks like a question came in online.
Adam, do you have a question from?
No, I was just repeating his question, typing it in for the live stream in case they couldn't hear.
Oh, okay. So
All right, so we're Project Heat. I'm Cooper McDaniel.
I'm Zach.
I'm Jonah Walton.
I'm Carson Burns. All right, so for our problem statement, when working in high temperatures with high humidity, it can get like really hot, especially for workers outside, like working on electrical boxes and that sort of thing. And so we wanted to design a way to reduce this kind of heat, and that can lead to like heat exhaustion, that sort of thing, by providing shade or even just like some type of cooling system, just to make it feel cooler out there for those guys working in the heat.
All right, and for some of our health and safety information, we saw that ultraviolet rays are from sunlight and they're a form of radiation, and these can change the structure of skin cells. And sunlight exposure during 10 a.m. to 4 p.m. is very dangerous, and that's kind of like the prime time for working, and it can lead to sunburn. So that's what we found with our information when we researched.
All right, so for the legal issues is like event organizers and people who run these companies, they can get sued if they have their workers or attendees suffering from heat stroke or there are other problems that come from the sun. And like events held on like hot days, they have to have like heat relief just so they can't be liable for problems.
Okay, so so just for a few like economic issues, there are devices out there right now, but that are like generally less efficient. There's portable air conditioners, which use electricity, and then there's like misters and that sort of thing that do help cool, but gets pretty pricey at some of the stuff. Okay, so there's technical problems. So people who are staying outside for too long, they're obviously getting headaches, they're very thirsty, they're sweaty, they're experiencing nausea, dizziness, fatigue, and impaired judgment, loss of appetite, and many other symptoms. These symptoms are just brought out because of the heat and all the strong UV rays they are taking in.
All right, so this is the previous solution attempts. So these are problems that are already out there, and we compared them to our design. And we used a scale of 0 to 3, 0 being the lowest and 3 being the highest. And then we ranked it with the cost, heat reduction, practicability, ease of use to compare the designs.
Okay, so this was our first idea. So it's an umbrella hat. So it is cheap. It's kind of portable, but it's not very practical. It does kind of make you look kind of funky. And so that's one of the cons that we really ruled it out for us.
All right, and then this was the portable mister, and it was very effective, and it is somewhat portable, but some of the major cons were it was very expensive, and it wasn't the most practical thing to bring that with you everywhere you go.
An additional and probably like the most like viable competitor was like just a regular deployable canopy. It provides lots of shade. It is sort of practical, but some of the top end ones can get like pretty pricey, reaching like $200-300. And they're not the easiest thing to lug around. It's easier than a portable mister, but like you don't always want to have that just laying in the back of your truck and stuff. And then just taking it out onto the site itself can sometimes be a hassle.
All right, so this is the way the solution development for our design, the next few slides. So our design criteria, the main ones at least, were the main goal of it was to be sturdy and block the sun while being out of the way, because the workers, they're not going to want to have a shade that they keep having to move while they're working in the sun. So the goal is just to be sturdy and just stay where they want it to. And this is kind of how we decided with the tripod design, which would like help it be sturdy but not have too many rods, but should keep it out of the way at the same time. And we also wanted to be adjustable and just be able to block the sun from whatever angle they choose. And that helped us choose the joints that we have at the bottom.
All right, and then another goal was for it to be cost effective and cheap to build. So we were looking to spend no more than like $30 to $40 on all the materials in the end. And then we wanted to have our final design by the end of the school year, so that was what our time restraint was. So we began to work with these restraints in mind.
Okay, so this is our final decision matrix. So As you can see here, the tripod magnet design had the most points in total. It wasn't the most cost effective, but it was had the most heat reduction, practicability, and ease of use.
All right, so here were some of our initial sketches. We began with only 2 poles originally, and then it would hold the shading and it would attach to electrical boxes through either clamps or magnets. So that was just our initial design that we had at the beginning.
And then just for our prototype alpha build, we have a few pictures after this, but we just use cheap wooden dowel rods to see what the best number of poles would be. And there were no real points of attachment. Everything was just kind of held together by tape. Then we had this piece of tarp acting as shade. There was no joints, and we still used the fishing magnets though to hold it onto the metal. And these were basically just what it was. Yeah, so as you can see, the wooden dowels, they weren't very sturdy, but the magnets did hold on to multiple surfaces such as a door or a bench. And it did give quite a bit of shade.
So the results that we got from the testing, like they said, they were flimsy rods, and we wanted a better connection to the magnets because I think at the time they was just duct tape and it was really flimsy. We'd like a better connection from the rods to the fabric as well, which was also just duct tape at the time. But the one thing we took away from it was that we did like the magnets, and we felt like the 3 magnets were a good addition to our design. But overall, it was no real shade provided, and it was just in the way a lot more than anything.
And then so for our final prototypes, we bought metal rods that we use. And then we also got these joint things that attach to the magnets. You'll see them on the future slides. And we're still working on the shade portion that we attach to the rods. Which you'll see. But these are the things. So these are just ball and joints, and they can go up to 90 degrees. And then how it works is you just unscrew the thing on the left. You adjust it to the angle you'd like, tighten it back, and then it won't move from there. Then you can just stick it onto the surface for the angle you'd like. And then just finishing up the build.
So for we had a mentor, and we consulted with James Moore, who's an engineer on Semiconductor, and we had a few virtual meetings with him. He helped us develop new solutions and decide on some of the materials to use, such as he helped us finalize the tripod design. I think he was one of the first ones to mention the magnets. And then he also mentioned a screen material for the shade, which would help with airflow. And then he also helped us decide what weight to use for the fishing magnets, so it wasn't too much.
All right, and then for some of our criteria, for the cost, we ended up going under our budget, and it fell under the $50 price target. It was around $40. And the materials were easy for us to obtain. We got most of them from Lowe's, and yeah.
Okay, so yeah, so it passed all of our design viability. It was very easy to use. It was pretty easy to assemble. Just screw in a couple magnets to that degree device, I guess, and then it's not too big, so you can lug it around, and yeah. And then so just a summary of our testing results. We tested it in the direct sunlight versus the indirect shade. It doesn't actually have a difference on temperature wise, but the feels temperature, if that sort of makes sense, how you hear the weather, there's the temperature, and then what it actually feels like. It does feel a little cooler when underneath it. And then we tested the strength and mobility of it in the wind. It did well, although the magnets were a little bit light. If we were to for this project, we were thinking about going with more heavier magnets. These were, I believe, 25 pounds, and we're thinking more of something like 50 or 100 would be better. That way, if it's at awkward angles where the magnet's not fully on the metal structure, it would still hold on decently well. And yeah, this is basically just us testing it. As you see, it works fine, just on a flat thing, but for it to actually go on the curved pieces, it fell. And then we never really got to finishing the top part. This was just from the prototype build, was this tarp. But we'd have to find something that was more like durable and not as flimsy as this piece of cloth.
So for the second test, the shade provided was good when it was on a flat surface. Because the magnets, they didn't really stick too well if it was like curved. The problem with the magnets was they might have been a bit weak. So we want to, like you said, just go to 50 or 100 pounds. And then on the top, we decided to add duct tape to both sides where we screwed in the rod to the fabric, and that just helped it be more durable and like helped the stability, and it was a stronger material around the attachment points.
And thank you.
Yeah, thank you guys for coming.
Any questions?
So was it actually able to hold up in the wind and not get knocked down or pulled away?
If it was like a completely flat surface where they were all on the same piece and they weren't like curved at all, it could. But even when there wasn't wind, if they like tried putting on like railings or something where the whole magnet wasn't on it, it would like hold for like 10 seconds until there was like a slight bit of movement, then it would like come crumbling down.
Any other questions? Thank you guys.
When there's two on this side, these seams get cut off. So one standing right there, right where that sign is, and then three right here. So if you could do that, that'd be a lot better.
So if three of you come on this side, it's way more than one on this side and just one on that side.
If you could stand back a little bit more, and then, yeah, you come in there.
Now, yeah, you're all.
Perfect. You're good.
All right, so we have our handrail sanitizers, what our project is.
I'm Preston. Yes.
I'm Dawson. I'm Jaden.
I'm Ethan. Who are you? I'm Ethan. Okay. So when we first started off, we started brainstorming a couple of our ideas. We came up with a pool camera to alert when someone was in the pool unintentionally, and then a car seat to detect if a child was left in the car, and then or a handrail sanitizing robot to clean all the germs off the handrail. And we first came up with our decision matrix. We had all different design ideas to begin with. Jaden had an idea of just a smaller attachment. Ethan thought of an adjustable train car. Dawson thought of a magnet track design, and I thought of like just one single train car.
Here are a few competitors or other ideas that do the same thing. This one is for an escalator. It sits at the bottom of the escalator and sanitizes it as it runs through. The pros of this design is that it obviously sanitizes the handrails, it reduces the germs, and it uses UV sanitization so that there's no residue left on the handrail. The cons is that you wouldn't be able to use it on a stationary handrail, and it's only made for the escalators.
So this is a portable fogging machine, disinfection machine. It's for sanitizing like rooms, big rooms. It's pretty easy to use, but it's not very specific to what we were trying to do, which was specifically like handrails. And it was pretty expensive. It costs around $115. And A con is that it uses human labor instead of like an idea that we wanted to go with, which was just a robot that could clean pretty much itself. And then also, we just have manual cleaning as a competitor. Again, this uses human labor, so it's not very cost effective because you have to pay someone to come in and clean the rails constantly. And so you don't really want someone to be like coming in and then wiping the rails down like as often as you would be. So pros of this though would be that it's effective cleaning and it's faster because someone can just go through and do it right and quickly.
And then, so for some of our designs that we were making, so we talked to Vance Carroll here at Desert Ridge, and he told us to make our design while thinking of cost, time, and efficiency. So here are a few of the designs that we started making. We have we wanted to make something that went almost all the way around the hand railings, just barely connecting. And then here we have the idea for the three train, the three cars in the thing.
Our funding was pretty good for this project. We got it on GoFundMe. We posted it on Facebook, our Instagram, and Twitter. We also included some of our own money and supplies we already had at home or in the room.
So some materials that we ended up using for this project, we ended up using magnets that were very small, round magnets. And then we ended up using 2-part epoxy to glue these magnets onto a track that would sit on top of the handrail. We had a lot of wires. We had high torque motors and battery packs. And we used Arduino to code our robot. And then we had 2 small breadboards to, instead of soldering, we just decided to go with small breadboards because it was easier to use. And then we ended up using a lot of filament, 3D printing a bunch of different designs for housing all of the components of this. And lastly, we had LEDs in place for our UV sanitization. So the coding, I started out coding this, and pretty much it's right here in the middle if you are interested in looking at that. But pretty much what it says is whenever you turn it on, the LEDs will turn on, and then when one of the switches is pressed, we have a switch on each end of the robot. And then when one switch is pressed, the robot will move in the opposite direction. Same for the other side. If that switch is pressed, the robot moves in the other direction. And then we just use the battery pack to turn it on and off.
This is the design we came up with in the end. We started with the box to hold the track and the magnets and the motors and the battery pack in the middle. And then we added the 2 boxes on the end to hold the lights, the circuitry, and the limit switches. And then we improved along the way, adding these brackets that go on top of the end railings or end boxes that will keep it on the railing better. And then, yeah, that's about it.
And then so this is a picture of our first test. We hadn't made the the 2 other carts yet, but we had the middle car that held the track, and then we held the 2 the Arduino boards and the circuitry in our hands. It went along the trail, but the motors run at very low speeds, so it wasn't going very fast, and it was very bumpy, but it worked.
So to start off with, our wires were pretty messy, so we had to clean that up as we went. After testing though, we wanted to improve some design flaws. We printed housing for most of the components. We attached our switches, secured the motors, and created a spot for the battery pack.
And this is what our project looks like currently. We fixed the wires and with electrical tape. We made caps for the ends of the boxes along with guide rails to help make sure that it stays online with the handrail.
So some future improvements that we would make if we had more time include some better balancing and stabilization, because if it's not leaning against the wall, it will still probably kind of lean to one side or another. So that's something we would like to improve on if we could. And then also brushes on each end is something we would want to add to wipe off any dirt along the path before the UV lights would go over it and start sanitizing. Because UV lights work better if there's no dirt in the way or anything. We would do a lot more testing for more reliability, and because the tracks, they sometimes get binded up, and we just want to make sure that doesn't happen and make sure it works smoothly. And then right now we only have the LED lights, and if we got to it, we would make sure we had the UV sanitization lights on there so that it would actually clean. And that's the end of the presentation. Any questions?
So how fast were you able to get it going?
It runs at 9 rotations per minute. Right? It runs at 9 rotations per minute, so you can imagine that's pretty slow.
And so you're using an LED as a stand-in for the UV in this case?
Yeah, 2 on each end, yeah.
So what would you do if you had a handrail made of different material? That wasn't
We did think about that, and we thought in the meantime, when you go to most amusement parks in most schools, it's really all just metal. And so we thought that magnets would be our best road for this to begin with.
Should we show it or?
You want to lift it up?
I just meant.
Yeah. That's the magnet truck on the bottom. And then, yeah.
Oh, we got a question. So what would you do if you had a handrail made of a different, same question.
Excellent, guys, thank you. Yes, 3 of you go on this side, it's better because it's very different.
I'll put the right button. It's just the right button. Yeah.
All right, so we're Team Skate, and our product is like skate trainers to help reduce injury while learning new tricks on skateboards.
I'm Owen.
I'm Ethan.
And I'm JC.
And I'm Dylan. And then we have another partner, Trevor, but he was able to make time.
This is just a table of contents that we put out for ourselves because our mentor Brian was actually really big on following the engineering process. And so we kind of just like laid out our entire presentation based on this right here.
So our problem statement is, since like the early 1970s, skateboarding has become very popular, and with that it has caused a lot of injuries, with about 98,000 people going to hospital ever since. And it gets really expensive fast with these injuries, and so we're trying to reduce these injuries with these skate trainers.
So the problems we're trying to tackle health and safety. So like Ethan said, over 98,000 people were treated in hospital or emergency rooms after being injured while skateboarding in 2017. We are also, like originally, like a big thing we had, we'll get more into this later when we go to our original sketches, but was the cost of skateboarding. A high quality deck and all the other pieces is usually going to cost you around like $150 to $170, which can be quite expensive for like new, beginners who might not know if they really want to get into the sport or not. And then the educational thing, we wanted to make a product that would help new people get into it, because we wanted to help grow the skateboarding community as a whole.
So for our first competitor, we have just protective gear like helmet, pads, knee pads, everything. This is a competitor because it helps the safety while riding skateboards. If you wear these, you're less likely to get injured. And
so this is probably our biggest competitor because it basically does the same job as what we were trying to do, right? It keeps the board stationary, but the only con about this product is that it is very poorly made. A lot of the reviews say that the product maybe lasts like 2 weeks, it falls apart, because in reality it is just 4 pieces of plastic that you can get for $20 on Amazon. But it does do its job, it does keep it stationary, and it does do all the jobs that we were trying to tackle, which is why it's probably our biggest competitor going into this project.
This is another competitor. It's a balance board. So you just stand on and you try and keep your balance, and it's a competitor for us because it's the educational purposes. It helps you learn how to balance better, and it could eventually help you skateboard better.
This is the Apex V brake. Essentially, this was supposed to help, it would clip to the side of the board and you would be able to step on this little lever up here, and it would essentially create friction on the wheel to stop it or hold it still. This product in our eyes was just trash. There's no price or ratings available either, so we have no idea if anyone has ever used this product, and we have no idea what anyone thinks of this product. So there's not really much to go on here, but we still consider it a competitor technically, because it can, in fact, this idea can in fact help prevent injuries.
So our matrix, we just compiled all those products in, and we kind of just went into and just see what our biggest competitor was, and the padding and the actual skate trainer, like I mentioned earlier, is probably our biggest competitors, just because it tackled most of the points that we wanted to as well. And so yeah.
Oh wait, okay. So the design that I came up with was the actual skate trainer, which is what we used. It is just basically a block that fits over the wheel, and it would hold the board stationary, and so you can learn new tricks. And this is what we ended up actually going with for our project.
And going off back to my concept, very, very similar, but instead of replacing just the wheel, or this thing where it slides over the wheel, I ended up wanting to replace the entire truck of the skateboard. And the only reason why I wanted that is because that also tackles the cost problem. Trucks, 2 trucks to buy, roughly $50. It gets you if you get some good pairs. And I wanted to replace the trucks, and I also wanted to come up with a square wheel concept. So you kind of tackle the cost and the safety aspect as well. So when you're learning the tricks, you have that square wheel. So yeah, that was just my design.
This is my design. It is quite similar to JC's. The only main difference was that I put like little legs on the bottom and reduced the surface area a little bit. But it was gonna be same idea, kind of. It was gonna be a complete replacement for the original heavy, expensive metal trucks. And the idea, like originally with this, was to kind of get rid of the cost of buying trucks and bearings and wheels, which by itself make up majority of the cost for a skateboard. Therefore, it would be more like skateboarding would become more accessible to beginners.
And so we just compiled them all into the matrix. Trevor's concept, and because he's not here, he can't really talk about it. His concept was just retractable pads, because he went with the idea of the padding just to protect your body when skating, and then Dylan had just a regular like stationary wheel. And so like we put them up here, and mine and Owen's like the specifications that we gave out, like it met those the highest, but because time didn't like really allow us this year, we ended up going with Ethan's concept, which even though it did score a 9 compared to me and Owen's 10, we still went forward with it because it was the one to move like effectively with time that we were given.
So the first stage, we're just measuring everything out, like seeing like the wheel sizes and everything just to get that down. And then we have to actually design it on Inventor, and then we tested it.
So this is our first prototype. Unfortunately, we didn't get any pictures before we tested it. I'm not really sure why, but basically it was made, this diameter, this inner circle was made to be 54 millimeters in diameter, which is like the exact same diameter as like the average skateboard wheel. And we printed it with a 50% infill. And we put this fillet on the inside. I'm not sure if you can see it on this picture, but that would just kind of follow the edge of the wheel so it like fits snugly. And yeah, the first, well, actually we'll get into that once we get there.
And so then we moved on to our second prototype because if you to go back to the other picture, you could see that it basically broke. And the only reason why that kind of failed is because of that 50% infill, because there's a lot of air pockets with the 3D printing, and it kind of just lost a lot of structure. And so we came into our second prototype coming up with we wanted it to be more sturdy. We also came up with these iterations of the holes in the corner, and our concept with that is if we were to take out material, no matter where you would turn the wheel, it would always fall onto the heaviest side. That way it wouldn't land on any corners. Right, and the corners is the biggest problem that we had, because even if you look on that broken picture, those corners just cracked. It just caved in, and it didn't do the job that we wanted. And so realistically, those corners didn't help, but it was our concept to move forward with in our prototype too. And so we did a lot of extensive testing with this one, and so we kind of made this chart to go off of when we were testing. Is the wheel fully connected onto, or is the trainer fully connected onto the wheel? Is it slipping? Did it land on the corner? If it did, did it break? If it didn't, did it break? Those kind of factors that we took in. So, and like I noted before, the structural integrity was lost. With the addition of the holes, we kind of ruled those out after we tested this one, because the wheels don't have that much time to spin around and then actually register where it is on the trainer. And so there's just not enough time in air. But yeah, that was prototype 2.
Our third prototype was basically, it was really similar to the first one. We removed the holes because, as we saw, the holes didn't help but hurt us. It was 54 millimeters again. And this time we printed it with 100% infill, hoping that it would be more sturdy and would actually stand up to, multiple tricks and all that. I'll talk a little bit more about this actually. So there was the idea, going forward, or we were deciding between whether or not we really wanted to try and make a piece like this, but something that could fit universally, because skateboard wheels aren't only 54, although that's the average. They can range anywhere from 52 to 60 millimeters. So we were really trying to tackle that for a while, and unfortunately we couldn't find a solution for that. There were definitely things that we could have done, but they were just out of our reach at the time, and with the amount of time left in the school year. So we kind of just stuck with like our idea of if we were to continue this, we would just make multiple sizes for each wheel, so you could grab the size of the wheels that you already had and just put them on and practice. And then this is our reflection. So in retrospect, our idea to attempt to make a new and improved version of the already pretty, well-known and respected skater trainers, it was definitely a difficult task, and we didn't quite make the product we were hoping for. Obviously, with the amount of time and the amount of cut time from this year, we didn't get as far as we would have liked either. And like I said, moving forward, we had a few other ideas that we were going to try and take on, but because of time, we had to stop here.
Yeah, so how well did your final prototype hold up in testing?
Well, we didn't get too many videos of it, and then again, we also didn't want to just like completely break all of our, all of the skater trainers that we did print, because these are actually the only 4 that we do have like with us, and so we did want it to show it off for you guys, just like all 4 intact, but we don't want to like test it and break it. But I'm sure this weekend I'll test it and see what happens. I'll record it. And so, yeah, if you want to reach out to us, then we can send you some of those results. So, but yeah, we actually didn't want to just break it and then just, this is our finished product, guys. So, yeah.
Just out of curiosity, does it need all 4 on to work, or like just like the front ones, or like how does that work?
Well, when we were originally testing like each prototype, we only had 1 at the time, and like we also did take that into consideration. Like, did it only break because we only had 1? Because what it does like if I was to take off 3, it would add like a bit of like extra height because it's like thicker, and we don't know if that's like was the cause of the break. You know what I mean? But if you were to practice, we would package this in a set of 4, so you would have all 4 to do it. Because if you were to just take like 1 off, it'll be like a wobbly chair. You know what I mean? And so that's a big thing when you're skating, because you don't want to be very loose and wobbly on the board.
So like, if you guys did like get the like machine them actually, like what materials did you go with?
So we had thought about that kind of during the same time we were thinking about like making a universal fit. We were thinking that we would love to make it out of some type of like rubbery plastic. So then it'd have a little bit of give, and it would also be like softer on like the landing, but it would still be firm enough to like just hold up the board and not move all that much while you're on it. But so yeah, I guess just I'm not exactly sure what type of material, but we were just thinking some sort of rubbery plastic, kind of similar to the other skater trainers, but yeah.
Nah.
Yeah, do it.
Yeah, do a trick, bro. I'll use it. First one. See if it works. First one.
Yeah, facts.
Oh, yeah.
Okay,
I can't.
Dude, over here.
Oh, yeah.
It's gonna shoot off.
Yeah. Oh, this could be dangerous. I haven't warmed up.
Just try.
I'll just try it. Here, let's just see if they're all connected to the wheels, all flat. All right. So that's my pocket. All right.
This is not fair to the people who are streaming right here.
That's true. Should we point it?
I got it. I got you.
I'll try it.
Hey, try
It didn't roll.
Flip.
Yeah, give him a big
Can I give it a test?
Try it again, bro. Yeah, Jordan, you can test it.
I've never skated, but I'll give it a test. I think I can.
Yeah, but it's the same.
Wait, can I do it? Can I try it?
Yeah, of course, bro. We're talking.
Come on.
You got it, dude.
Wait till our ski trains.
I actually want to get a kickflip.
Oh. Hey, but it still worked.
Am I in the right spot? You might, I don't know where the alignment is.
It's okay, you know.
Just try it. Oh, are we still doing? Yeah, they don't know how to.
That was solid.
No way, no.
I haven't tried to on that one. We are still focusing.
Actually looked like it.
Well, you won't shoot out.
Yeah, I know. So we'll just make them do it again later.
Where's the,
I mean, this one.
Could one of you move to this side?
Yeah, because only one person can really show up there. Perfect.
And you scoot back a little bit. Yeah, and then you scoot.
Yeah, here all.
Perfect.
So we named our project Seatbelt Sentinel, and my name is Brian.
I'm Zach.
I'm Julian.
I'm Mason, Shem Feet here.
So we want to start with some competitors. So this right here is the Acilla Baby Hot Seat, which is basically trying to tackle the same idea that we had, is to have some sort of like sensor mechanism that would allow like its user to know if they left their child in the car or if they forgot like to bring them with them when they were out without not paying too much attention.
One of the main things that we do want to point out about this company is that this was a girl in Texas. She basically had the same idea as us, and it was for a science fair project. And after she created this, it's based off a weight sensor, and it detects and makes an alarm based off if the child's still in the car and the temperature reaches a high enough temperature that like it's dangerous for the child. Recently, though, her patent actually did expire, which gave us the idea to use some of her ideas because we couldn't technically have legal reasons against it.
So Hyundai is planning on putting a similar mechanism into all of their cars by the year 2022. And like it's got a lot of good technology behind it, but the main cons behind it is that you have to buy an entire car for this to even work, and it's only appearing on the new Hyundai model. So if you have an old one, sucks to be you. So our goal to compete against this was to make it universal for all cars, not just new Hyundais.
We saw a similar thing with the Eternus S Sensor Safe by Cybex. So this is just one of many. Essentially, it has the same kind of deal where it plugs in, electrical contact is made, and it communicates with the parent with a beeper or a phone app, just depending on which one it is. So the cons here are if you already have a car seat, like a hand-me-down or you're reusing one second-hand, you can't really use this because it requires a car seat. And a lot of them had an issue too where on the mobile app you could only have one car seat at a time. And some people were running two, some people were just running one. And then the retail value for each of them differs, but they're all going to be higher than if you just bought the car seat.
And finally, we've got the LFO eClip Baby Reminder Car Seat Alarm. This is basically an attachment that you can put onto any car. It is cheaper, which makes it nice, but the only con that we found about this, as Julie mentioned before, is that it only lets you use one car seat or one alarm, and you had to restart it every time you went on a drive, and if you forgot to set the alarm on your phone, it would not actually be activated throughout the drive. So in our project, we wanted to take into the concept that you wouldn't have to go into an app and actually figure out how to start an alarm, and it would just automatically start sensing whether or not the child's in the car or not.
So we basically saw like doing the decision matrix behind each of our competitors and seeing like which one has like the best and worst components, each of them. And as you can see, like the Eternus and the baby seat, they both scored pretty high, but that also plays into like their high price. So yeah.
We're not going to make you guys read the entire problem statement. Basically, what we decided was that we noticed every year we hear on the news, because we live in Arizona, it's really hot, that we hear about 50 deaths a year because of children that were left in their car because it's too hot outside or it's too cold outside. This is actually, studies have shown, like with doctors and psychiatrists, that there's actually a syndrome called forgotten baby syndrome because parents and legal guardians have too much going on in their brains at the moment that they happen to forget a necessary aspect of their lives. But we basically, when looking at it, everything either we needed to take into account whether or not like temperatures would work for electronics, what the cost-effective properties would be, because as we saw earlier, you can either buy an entire car, an entire car seat. Those are going from like $300 to $3,000 at least for the car seats, and like more than that for the cars. So our main thing was that we wanted to make a cheap, portable, compactable little attachment that you could put onto any car seat that could work.
So we wanted to make sure that the cost of production would not exceed $30, so then it would be a cheap product while also make great profit. We wanted to alert a parent maybe like after 30 seconds, so then like if a parent shut off their car, they were still getting things out of the car, it wouldn't just alert them when they're still at the car and about to get their child anyways. And we wanted it to be easy to engage and disengage, just have it activate immediately and just have like a shut off switch on the thing. And we wanted to make it a very compact size so it wouldn't be cumbersome and they wouldn't mess with it too much.
So one thing that we were unable to get to because of time and everything like COVID and all of the other problems that we experienced throughout the year was that we wanted to introduce an accelerometer onto the circuit so that you could have like and detect when the car's in motion versus when it's not. But because of time and trying to figure out what the coding and the wiring of it would be, we just decided to scrap the idea so that we could just continue with the idea of a speaker, an LED, and a temperature sensor so you can measure just like how hot it is outside.
In early development, there was also the concept of using a weight sensor, but we found that that would also have a large margin of error.
So, to elaborate on that. We had originally had this idea where we would have some kind of temperature sensor, and we knew we wanted to use a Hall effect sensor, which is, if you don't know, just a magnetic field sensor. So, as Mason mentioned, we had this idea for a weight sensor, and then we had ideas for making an app, and then even like radio and a little key fob. But a lot of those ideas we scrapped, not just because of time, because that was a little bit of an issue, but it's also because some of the stuff was really difficult to do. So we saw from very early on that the app wasn't going to happen. And then we ended up having to drop the radio because it wasn't working super great. We couldn't quite figure it out. And the temperature sensor, we figured out worked pretty quickly as well as the Hall effect sensor. So we just ended up having to drop some of those things, but that led us to a more simpler design that's easier to produce and reproduce while still maintaining its effectiveness.
In the consideration of the design viability, we talked about how, like, what temperature we wanted to make sure that we would have the temperature sensor set at so that it wouldn't go off, like, when you're driving, so you can make sure, like, it's actually a temperature that can actually be harmful for the child, but you still get to the child before any damage could be done. We made sure we discussed that idealistic temperature would be 85 degrees, or I think it was 26 degrees Celsius is what we put into our code.
But in other terms, we're basically just wanting to make sure that it's comfortable enough for the child, but you're able to react and figure out what you're going to do in the situation if something like this were to ever occur. Like, we want to make sure that this is more of a prevention instead of like a pointing out that you're unable to take care of the child instead.
So in the construction of our testable prototype, we started with a modification for the car seat to hold everything underneath it. Most of this testing was completed during the coding phase, and it was one of the most difficult parts of the entire project. Some other things that were developed during that time via coding were most of the sensors, the Hall-effect sensors, and the speaker. So our data collection plan is confirming that the code ran smoothly on Arduino. We used Arduino to code all the sensors, and we wanted to make sure everything actually worked properly before we started developing like housing and everything. We wanted to have everything functional running at the same time, and yeah, just making sure everything works correctly.
We just thought we'd throw in a slide that basically was talking about our mentor recommendations from our last meeting before our presentation. We wanted to talk about how like we recorded the main test, but we also wanted to elaborate on the idea of when we were testing our product and our prototype, we only were able to test the prototype in a controlled situation instead of being able to test it in the car. So later we're going to actually demonstrate the product for you, because what we planned on doing was that we wanted to present it so that you could actually see the wires and circuitry and actually see the sensor and the alarm and the beeping and everything go off, as well as seeing like how the magnets are going to clash together on the harness. But what we wanted to do was complete the coding as soon as possible from our last meeting, which we did finish. And then we weren't able to do a main test, but we did realize that in order to present this for you guys tonight, we changed the internal temperature of it reading to 20 degrees Celsius, which is about 60 degrees in the room. And in this room, it is higher than 60 degrees, so the sensor will work when we test it. And then we wanted to make sure that we continue working on our portfolio for this presentation.
So consider this more of a proof of concept that it does work. And we have tested it with lower temperatures. We've tested it with slightly higher temperatures and used stuff like heat gun or even a hot glue gun to try and get it to work. And it does work. And so we'd be happy to demonstrate after our presentation.
As we said, basically right there. And then for the reflection, basically our group, because of COVID, and we were in hybrid during most of the year, we were split up into two groups. It was 5 of us and then 1 of us on the opposite days. So when we did that, we used Google Apps and emails, WebEx, text, working on the same document. Once in a while, we would just leave sticky notes for each other so we could tell each other what we needed to work on for the next day. Any way that we could communicate with each other and be able to focus on the projects that we needed to create, as well as any side projects we were assigned, and then make sure that we could finish everything on time and not actually just like sit around doing nothing because we aren't sure what the other group was doing during their time.
Eventually, our communication did evolve into a group chat, so
Yeah.
that we can actually have much more effective communication than just a random sticky note that we might not see.
Yeah.
Don't worry, guys. We figured out how to use iMessage, and it only took us 6 months.
And then for this project, it basically helped us get a new perspective on things that we're working on, that we could look at projects and look at problems in the world, look at it and how we want to improve, how we can provide solutions towards things in the world. And that's basically what my perspective would define as an engineer, which is basically just looking at everything in the world, trying to find a solution, and then how everything could fit into our lives if we were going to make a solution. Any questions?
So when you first get in the car, since we live in Arizona, it's pretty hot. Is it just going to be going off? Like
We
right?
we were planning on making a little button on it that's like a turn off button.
A snooze.
Yeah, a snooze button, so that basically it knows, hey, there's no problem.
Or that, or just like create a little bit of a delay.
Yeah.
Yeah. So we did think about stuff like that. We had to kind of put the snooze button on hold to get everything else working. But the way it works right now is when you buckle the baby in, there are actually two, and we have them here. So we have these two little pieces that will sit directly under the chest buckle, so that when you buckle them in, these will connect together. And in one of them, the Hall effect sensor is going to sit, and in the other, it's going to have some magnets. So when they're buckled, the magnets will put together. And in the code, that tells it that the baby's buckled in, and then it'll check the temperature.
And then one of these pieces will be and then the piece with the Hall effect sensor will be wired all the way into a box that holds the rest of the electrical components that will also have a slot for the speaker and the LED to extrude from the surface.
So because you have the little magnets that are holding together the Hall effect sensor and the harness, once you put it up towards the Hall effect sensor, it'll start beeping because it says that our temperature is higher than 60 degrees or 60 degrees Fahrenheit at the moment. And when you take it off, you basically unbuckle the harness and it will turn off the sensor.
If we were to actually take this project further, we'd probably get somebody to either do an app or we get a much louder speaker, so it'd be a lot more attention around it, other than just somebody that may be 2 inches from the car.
Yeah. But you got to keep in mind we're on a high school budget and the very little money that we were able to get from a GoFundMe or anything like that.
Thank you for your question. Anyone else? Go ahead, Dawson.
Would you guys eventually make this waterproof if we were to go on further? Because you gotta imagine.
We were talking about making a protective casing, and we weren't sure if we were going to use PLA filament or if we were going to use some kind of other plastic that we could use to encase the, basically encase the wiring. We were intentionally trying to put it inside the little clip so that it could just be all one portable thing. And if we weren't, we were going to make a little box full of electronics that could sit right underneath the car seat. Because if you can tell from this one, a lot of car seats actually have a little compartment underneath that you can slide stuff into. So we were thinking that you could put something down there, or we were just going to make it so that everything was compact. We actually almost finished soldering, but then we ran out of time. And we were going to have basically an Arduino Uno connected to a motherboard that was basically this big, so it would have been compatible enough.
So basically what the idea was is that it would connect these and then there'd be a wire also, and obviously a protective insulation around it that would lead into the box, and it would all be completely sealed so no electronics would have any possibility of actually getting any water on it. Any other questions?
Thank you, by the way.
So anyone join us by stream? That was the last presentation. We're going to take a tour around here, and I'll probably end up putting a tour online separate from this where we'll go around and show the engineering thing. So until then, I'll see you all. Go ahead. Excellent. So